I'm going to just talk about the problem number 70 from the class that we did. It was in class assignment. And so let me just finish this. And this problem is going to conclude chapter 15. I mean, we've covered all the basic types of problems that are encountered in chapter 15. So normally we would have a test like the next week on chapter 15, but I'll probably move it to Tuesday the following week. Give a little more time for that. But we have the amide hydrolyzing water. This is going to form ammonia and hydroxide here. What was the original initial 0.0125? Was that it?
Yeah.
Okay. And if we do the normal setup here, it looks pretty easy actually. Minus X molar, plus X molar, plus X molar. And so 0.0125 minus X molar, X molar, and X molar. And so K for this was 10 to the 20th, which is going to equal the ammonia times the hydroxide. I'm going to stop writing equilibrium on here. So if it's a K, it's always taken as equilibrium. If it's a Q, it's always taken as whatever you're given. Divided by the amide concentration. Activity of water is 1. Its concentration won't change. It's like 55.5 molar. All right, and then we'll do this. X squared over 0.0125 minus X. And this is just a quadratic, so quadratics are not difficult to solve. So let's go ahead and take a look at this one. This is going to give us, just going to get this into quadratic form. So it's going to give us x squared plus, I'll just write it like this in scientific notation, 1 times 10 to the 20th x minus 0.0125 times 10 to the 20th. Is that right? Quadratic, and then this is equal to 0. And so there are 2 ways you could do this, 3 ways actually. One, you could just plug in A, B, and C into your calculator. Did anybody buy that the fancy calculator, the $16 one? The Casio? Yeah. And so just tell me what you get from this one. If you didn't, then we'll just do it by hand. But you know, if you're at home and you don't have the fancy calculator, we don't necessarily need the fancy calculator at home because you could use whatever resources you have at home. And so there are lots of quadratic equation solvers on the internet. So if you just search, you can go, maybe we could try the Wolfram Alpha quadratic equation solver. Wolfram makes this math program, pretty widespread, Mathematica. And so all we have to do is we plug in our A, we plug in our B, we plug in our C, just like you do with the $16 calculator. And so we'll go ahead and, did somebody do it?
1 over 80.
And so you got x equals 1 over 80,
Yeah.
which equals, okay, hit the S to D
That's
key.
0.0125.
Okay, which is 0.0125. And so doing this, we get 0.0125. So we got 0.0125 minus 0.0125, which gives us 0. And then over here we get 0.0125 and 0.0125. And so it looks like it's 100% hydrolyzed. Well, that's what you learn in Chem 1A. You learn that strong bases hydrolyze 100%. So this just confirms fact. But you know, we always want to double check our answer. So if we double check our answer, what are we going to get? So if we double check our K, the K is going to approach infinity. And so what is our percent error in the K? Well, K is supposed to be 10 to the 20th. Our double check K value is infinity. what's the percent error? Well, the percent error is going to be infinite percent error. Is that good? Infinite percent error? No, I mean, it's pretty bad. And so this is not what we want. And you know what happened there is maybe I shouldn't have told you to buy the $16 calculator. Maybe I should have told you to buy the $100 calculator. Maybe that would do it, right? Well, we might as well just use Wolfram to do this for us. So let's go ahead and plug in A. A is 1. B is 1 times 10 to the 20th. And then C is, I'll just leave it, 0.0125, so I'm not even going to move the decimal, times 10 to the 20th.
Negative.
And then let's hit submit.
Negative.
Oh, is it negative?
Yes.
Negative. Okay, and then I'm going to hit submit. Let's let Wolfram calculate it for us. Do I have to pay money for this? Is that why I'm not getting any numbers? Oh, very good. All right, I've given up on that one. I thought it was going to work. But there are plenty of others online. And so let's just go to the math is fun quadratic solver. You've got 1 times 10 to the 20th, 0.0, so 125. Remember, 0.0125 times 10 to the 20th. Okay.
Did you put in negative?
Yeah, did I? No, I didn't put in negative. Shoot. Yeah. Same mistake twice. Negative. So now this has all the computing power of the whatever. But take a look at this. So this is the same answer as your $16 calculator has. And so maybe the $16 calculator is okay. Because if you bought a $100 calculator, you know what your answer is going to be? It's going to be the same thing. And so actually this is not right because the percent error in the k values is too huge. So we have to come up with some other way of solving this. And coming up with some other way, David had the idea. We got to start thinking. We got to start thinking of some trick or something that we can use to solve the math on this, because this quadratic solver here is not working. Wolfram's not working. All these. So what can we do? Well, one of the things we could try to do is we could try to do the simplifying assumption, maybe. Remember the simplifying assumption? The simplifying assumption is we could just assume that the change is small here. If we assume the change is small here, right, then maybe that'll work. So let's go ahead and do that. I'm going to go ahead and assume the change is small. And So we'll get x squared over 0.0125. In other words, the change is negligible compared to our initial. This would be the change as our initial. And then let's solve for x here.
Would you have to reset it first?
Well, why?
Because the x right there is the mean. And that's almost 100%. So it's going to be negligible. See what I'm saying?
I see what you're saying. But, I mean, did anybody else catch it? You understand why David's saying I'm wasting my time because I shouldn't use a simple. We already know the change is going to be huge. When I see this, it's 10 to the 20th parts of product for every 1 part of reactant. And so that tells me it's all product. So this is totally lopsided. Right now it's all reactant. And what I have to do is I have to shift all the atoms over to product. If I have to shift all the atoms over to product, then the change is going to be not small and negligible. The change is going to be huge. But, you know, even if you don't want to think, let's say you're on cruise control, you don't want to think, you know, you just want to punch the numbers. If we were to punch the numbers, what would happen? And so look, I'm going to go ahead and punch the numbers. I'm going to get 0.0125 times 1 times 10 to the 20th, and then I'm going to take the square root of that. And so square root of the answer there, and I get an x value of, let me tell you what it is, 1,118,033,989. And I go, one, does that number make any sense? No. And two, is that a small change? This is ridiculous. We can't even have this change. I mean, the biggest change we can have is 100%. And so this is a big fail. The simplifying assumption failed here. And so now we got to think, well, maybe we could do successive approximations. And in the morning, one student tried successive approximations and got out to 13 digits and still was way off, way off. And so we're running out of options. So, you know, what I hate to see is that people leave a blank page, which happens so often in Chem 1B. People get stuck and they don't try. And so let's think of something we could try. And the thing we could try is resetting. We didn't try resetting. In fact, I would, you know, even before doing this, the first thing I do is I look, should I reset this or leave it alone? And so when I solve a problem like this, I go, do I want to reset it or leave it alone? If k is very small, I would leave it alone. If k is very big, I better reset this. And now it depends on what side we have. And so I always look at my initial and see, is my initial close to the ratio or is my initial far from the ratio? My initial is far from the ratio. I mean, because if you look at this, I get 0 from this as my Q, and I'm pretty far from 10 to the 20th. So what I want to do is I want to go, well, actually the opposite. The opposite is going to be far from it as well, but at least it seems to mimic it. And so we're going to reset this. We're going to reset it, and there's only one way to reset it. We're going to reset it right. We're going to reset it right because that ratio of product to reactant is heavily product favored. And so when I reset it, I'm just going to reset the entire thing. So this reset's pretty straightforward because everything's 1 to 1. So this is going to be minus y, plus y, plus y. And I use y when I already know what y is because I know what y is because I look for the limiting reagent. Limiting reagent, I have plenty of water, so I don't have to worry about that. And anyway, the concentration of water doesn't change, so it's never included in the ice table. So here it's going to go down to 0 molar, and so that's going to give me 0.0125 molar and 0.0125 molar here. All right, this is my reset initial. And so if I reset my initial like this, well, it can't be this. It's not 100% reaction. Do we have 100% reaction? No, we have something slightly less than 100%. And so what's going to happen is it's going to go backwards. That is, I got to go backwards, lose some of my product, and then gain a little bit of reactant. Not much, but a little bit. And so here the change has got to be small because I don't need much reactant to get that kind of ratio. And so I end up with x molar here, 0.0125 minus x molar, and then 0.0125 minus x molar here. Now when I look at the algebra is a little bit more complicated than before, and so this reset didn't save me, because now I actually have to multiply out of binomials here, and this is going to be divided by x. And so this is also quadratic, so we should be able to solve this. And this is going to come out as x squared minus 0.0250x, and then 0.0125 times 0.0125 is what? 0.0125 squared. 0.0125 squared is 000. 15625. So I'm going to carry all those digits. 15625. Okay, this is going to be divided by x. And now we'll get it in quadratic form. So I'm going to multiply both sides by x. So I'll get 10 to the 20x. And so it's going to come out as x squared. Okay, then I have 10 to the 20th. And I'm going to subtract that from each side. So it's going to be basically 1 times 10 to the 20th x, because this is pretty small compared to that. And then plus 0.00015625. And this is going to equal 0. All right, and so one thing you could do is you could just plug this into the quadratic formula and get your answer, you know. But I don't particularly like doing the quadratic. I like just punching in the ABC. It's much easier. And so let's go back to the Math is Fun website, and then I'm just going to plug it in. And of course, you could use this for your homework. Unfortunately, you cannot use this website for the test. And so, if you want to save yourself some work on the test, you're going to have to get one of these calculators. Zero, 1, 6, 2, 5. Okay, I think that's right. Yeah, so I got 1x squared minus 1 times 10 to the 20th plus 0.0001, 15625. 15625. Okay, here's the formula here. X squared minus 1 times 10 to the 20th, which is a big number in the middle, plus 0.00015625 is equal to 0. And so let's take a look at the roots. The roots are 100. 1 times 10 squared is 100, and 0. Did I mess up the algebra? Did I mess up the algebra? Because how is it possible x is 100? I mean, if it were 100, I'm going to have a huge negative molarity. Is a huge negative molarity possible? No, it's impossible. Is it possible that x is 0? Yeah, x could be 0, but that says 100% reaction. So what's happening with this? You know, whatever algorithm they're using here isn't carrying enough digits. You know, your calculator, the same thing's happening with your calculator. Even if you bought the $16 or the $100 calculator, it cannot carry an infinite number of digits. There's a finite number of digits it can carry. Do you know what that number is? You could look at it in your the manual that came with it. Like this $1.99 calculator carries 10 digits, as I recall. I looked it up, and so 10 digits is not bad, but 10 digits is not enough for us. Unless, did somebody get an answer for this?
Yeah. 1.5625
1.5625
times 10 to the negative 24.
times 10 to the negative 24 using your calculator with the solver. You get 1.09 times 10 to the negative 38, and you get what kind of calculator do you have?
I have the TI 36 Pro, 36X Pro.
Uh-huh.
Mine's 10 to the negative 25.
Times 10 to the negative 25. Are you guys on non-programmable or programmable calculators? Those non-programmable?
That's poly solved though.
Okay, that's good. Okay, you could go ahead. Calculators are getting better. Then TI 30X Pro. Does anybody have the Casio FX115? And you got 10 to the. You got this answer too. You got the okay. All right, so it worked. That worked. So we could use a quadratic formula. We should get the same answer. Why didn't it work here?
Because this math isn't fun.
Well, Wolfram, it's got to work in Wolfram, right? So let me just plug it into Wolfram. I mean, come on, Wolfram wrote the Mathematica program. 1.0001565. Okay, well, I've worked in Wolfram as well. X, now, did somebody say they got 10 to the minus 25 or 10 to the minus 24?
I just changed it.
You got 10 to the minus 24, everybody? Okay. And so this is the answer by solving the quadratic equation. X is equal to 1.5625 times 10 to the minus 24. But there's still hope for you. If you didn't break down and buy one of these fancy calculators, you could do this with a $9 calculator quickly. If we do something, and the thing we could do is this. We expected a huge amount of reaction in the forward direction, but in the reverse direction, we expected a very small amount of reaction. And so let's see. If we solve the quadratic equation in which we make no assumptions, this is what we get. However, we could make this math a lot easier if we just go ahead and make an assumption here. And what is that assumption? It's the SA. The SA stands for simplifying assumption. So I'm going to go ahead and make the simplifying assumption, except in this case I'm going to put these two binomials together. So it's going to be 0.0125 minus x quantity squared divided by x, and this is equal to 10 to the 20th. And so if I make this simplifying assumption, I'm going to assume that x is negligible compared to 0.0125. So I'll get 0.0125 quantity squared divided by x. And so let's solve this for x. And so I'm going to get x is equal to 0.0125 squared divided by 10 to the minus 10 to the 20th. And so x is equal to 0.0125 squared divided by 1 times 10 to the 20th. And look at the answer. I get, using the simplifying assumption, I get 1.5625 times 10 to the. That's the same answer as that guy who wrote Mathematica, And that's pretty impressive because we got the same answer. We did it so easily just by using the simplifying assumption. Because the reason it works so well here is because of the percent change. If we calculate what is the percent change in this, remember the percent change should not be greater than 5% because 5% is really pushing it. And so we're going to go the change, which is this, over the original. So I'll take the change over the original, which is 0.0125 times 100. And the percent change I get is 1.25 times 10 to the minus 20%. Is that much change at all? No, and this is so far below 5% that the simplifying assumption works really well. I mean, phenomenally well. I mean, there's no point in, if every problem was like this, there's no point in buying a $16 calculator. There's no point in opening the quadratic equation solver on the web.
On a test, would you, do we have to round to 1.6 or 6 big?
I don't want it rounded until the very end. You're not allowed on tests. Let me tell you, on tests I'm kind of particular. If you're uncertain, don't round.
Okay.
I hate answers to 1 sig fig because 1 sig fig always leads to huge rounding error. Let's say you earn 0.4%. Let's say not 0.4. 1.4% interest on your savings account. Not that it would be that high, but let's say you earn 1.4% interest. Let's round that down every day. Every day I'm going to round that down to 1%. What's going to happen at the end? At the end of the year, you're going to have huge round-off error in your accumulated interest. So I don't like to round until I'm absolutely sure I'm at the end of the problem because I don't want any errors to introduce into it. And so anyway, going back to this, I would just leave it. And so I have x is equal to this here. Now I don't know, is that correct? And so let's go back over here. And so that means the amide concentration is going to be 1.5625. These digits aren't significant, but why do I carry extra digits? I carry extra digits because I want to do the double check, and I don't want a huge round-off error when I double check my K value. And so this is going to be 1.5625 times 10 to the minus 24 molar. Now, what should I do with this? And you might think this is a little weird, but we're going to do it like this. Plug it into your calculator and tell me what we get. If you plug it into your calculator, we're going to get 0.0125 minus, actually I don't want to write it all out, I'm just going to write 1.5625 times 10 to the minus 24. So do that. Take 0.0125 minus 1.5625 times 10 to the minus 24. Tell me what you get in your calculator. 0.0125. Could that be right? Could that be right? Mathematically? Or conservation of math? No, this is not the right answer. And so your calculator failed. The reason your calculator failed is because of round-off error. So we're not going to round off. We're just going to go for the whole thing. And so I'm going to go 0.0125. Actually, I forgot that. No, maybe I am. And so 0.0125. And the problem with your calculator is, even if you have a more fancy version, my calculator only handles 10 digits. So even if I can punch in extra digits, more than 10, when I hit enter, or when it takes that entry and does a calculation, it's only going to carry 10, and it's going to round it. And so what we'll do here is we're going to carry extra digits because we can carry a lot more than the calculator. And so here, I'm going to go and I'm going to write 23 zeros. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. 23 zeros and then a 15625. 15625. Okay, then I'm going to just add zeros here. So let's see. I'll just line them up and just add zeros. Okay, and then even though our calculator couldn't do the subtraction, we can. And so 10 from 5 is going to be 5. 9 from 2 is 7. 9 from 6 is 3. 9 from 5 is 4. 9 from 1 is 8. And then, I misaligned. 0, 0, 0, 0, 0, 0,
Should be 9.
0, 0. Did I make an error?
Should be 9.
Yeah, sorry.
A bunch of 9s.
Oh, 8. You're right. 9, 9, 9, 9, 9, 9, 9, 9, 9, 9, 9, 9, 9, 9, 9, 9, 9, 9, 9, 9. Oops. Oh no. Okay, I can back up. Back up. 4, 2, 1. 0.124.
There you go.
3, 6, 9, 12, 15, 18, 19 nines. 19 nines and then an 84375. And so that would be the molarity here for both of those here. And so it's just, you know, it's just a hair under, not even a hair. I mean, what would you call that? Like, we barely lost any. You know, just a tiny, tiny bit of this. Obviously, it's going to round to 0.125, but we want to know how much we actually lost. And so, can you imagine? Well, anyway, let's go ahead and do our double check. And so that's the molarity here. That's the molarity here. Now I know my actually, if you don't know how many digits your calculator holds, then just try to enter all of them. And so what I'm going to do in my double check is I'm going to just plug that in for the ammonia. The same thing for the hydroxide. So I'll take this number and square it, and then divide it by this number. So I'm going to just go ahead and attempt to put those into my calculator. And we have 0.124, and then I'm just going to count 19 nines. 1, 2, 3, 4.
124.
Oh yeah. Okay.
Just in case.
Yeah, you're right. That would have screwed it up. And so 0.0. Thanks. Okay. So I'll just try. You know, I know there's no use in having that many because it's going to round it anyway. So, but I'll just try 0.0, 1, 2, 4, and then 19 nines. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 8, 4, 3, 7, 5. There's no way your calculator is going to carry that many digits, but I'll just go ahead and put that in and let it round itself, and then I'm going to square it. So I'll square that equals, and then I get 1.5624, 9999998 times 10 to the minus 4 divided by 1.56, 1.5625 times 10 to the minus 24 times 10 to the minus 24. Oh, did I do that right? Yeah, this one squared divided by that. I think I did it right.
I got 10 to the 20.
You got 10 to the 20th? 1 times 10 to the 20th?
Yes.
All right. And so, what did you get? 1.0 or 9.99, or what did you get?
Just 1 times 10 to the 20.
1 times 10 to the 20th. Is that a good check? That's a good check. Now we can feel comfortable that our answer is on. You know, even though it seemed kind of ridiculous to carry that many digits, this is the reason we might want to do it. Otherwise, we're always uncertain. Is that, you know, difference due to some error, or is it due to rounding? And so it would have been due to rounding in this case. Okay, that's it for this. So again, chapter 15, that's pretty much it for the types of problems we're going to encounter in chapter 15. So just take a look at the homework. If you have questions regarding the homework, we can get those answered next week. And then today's lab, we're going to start the known. As I said before, with the known, you can work with a partner. I wouldn't suggest working with a group of 3. The reason is typically when we have a group of 3, there's not enough work for 3 people to do. A group of 2 is good, but a lot of people, when they do a group of 2, they split the work. Okay, you do this part, I'll do this part, right? And so when it comes down to them doing their unknown entirely on their own, then they come up to me and ask me, you know, ridiculous questions like, you know, this is for their unknown. They shouldn't be asking me questions like this. You know, we don't have any 16 molar 16 molar nitric acid. You know, we don't have any 16. Then I know, wow, they weren't paying attention during the known because we don't have any 16 molar nitric acid. The procedure asks for 16 molar nitric acid, but we have to substitute 15 molar instead because that's what we have in lab, 15 molar, not 16. And so the thing is, even if you work with a partner, you want to be very involved. In fact, both you and your partner should analyze the colors, the forms, the steps, the separations, everything together. That way, when you do it on your own, you'll be much better prepared. All right, that's the known. The known solutions are going to be in the stockroom. Did I tell you about the student? I had a student doing this lab on this day spill some solution on her hands, and got a whole bunch of silver nitrate stains. Silver nitrate. One thing about silver nitrate, what is it? Well, one, it's a heavy metal. So you got to watch out because silver likes like sulfur-containing proteins and stuff like that will precipitate. It's also a oxidizer, and it's a pretty decent oxidizer. So it can easily oxidize your skin and precipitate out silver metal. And so she had a whole bunch of silver metal precipitated out, and it forms these brown, black splotches. And she told me did I already tell you this? She told me she was washing her hands for like 45 minutes nonstop. And I thought, oh, wow. The reason why is she had an important job interview and she didn't want a whole bunch of silver nitrate stains on her hand. But unfortunately, there's no way to wash them off. You just have to wait until they show off. So silver nitrate, watch out for that. We're also working with a very powerful oxidizer. What is it? This is a very powerful oxidizer we're working with. Peroxide, hydrogen peroxide. But you might go, wow, hydrogen peroxide, I can buy that in the supermarket. What's so hazardous about hydrogen peroxide? Exactly. The one in the supermarket's super low concentration, which brings us to a very interesting story. The one we use is, I think, 30%. There's a story about this person who traveled to the Los Angeles area, and they saw some 30% hydrogen peroxide for real cheap, And what they wanted to do is they wanted to bring it back with them to Northern California, and so they bought the hydrogen peroxide. This is pre-TSA check and all the security measures now, but they were able to convince the check-in person that, hey, it's just hydrogen peroxide. You buy this stuff in the supermarket. It was packaged in a 1-gallon milk jug, so they said, okay, it's okay. It's just hydrogen peroxide. And the supermarket stuff's 2%. Well, during the flight, it started to eat through the milk jug that they used. It ate through it, and then ate through the luggage, and then came into contact with fabric luggage and caught it on fire. So there was a fire inside the cargo bay, and they had to do an emergency landing. You could read about the story. It's really well known on the internet. But hydrogen peroxide is nasty stuff, and you got to know it's nasty stuff because what are you doing with it? You're converting chromium-3 to chromium-6. Aren't you familiar with chromium-6? You saw chromium-6 as dichromate, and what did we say about dichromate? Dichromate's a powerful oxidizer. Well, what do? If you're going from hydrogen peroxide to dichromate, then dichromate must be a weaker oxidizer than hydrogen peroxide, otherwise there's no driving force. And so you think about that. This hydrogen peroxide you're using is more powerful than dichromate. Okay? And that's because we're using the 30% stuff. Some labs they use 50%, which is really nasty and kind of dangerous, especially around organics. And there have been many, many explosions. In fact, peroxides and organics are, if you take a look at it, are what they make a lot of explosives out of. Okay. All right, and so be careful with the contact. We have, we have fume hoods here for any hazardous procedures. But today, I was surprised because did I mention anything about the wire? The sodium test and the wire. Did I mention anything about that on Tuesday? Yeah. Today, some people were cleaning their wire first. And not only that, they're cleaning it with hydrochloric acid inside the lab, not inside the hood. If you're going to use hydrochloric acid because it has very corrosive fumes, do it inside the hood. And so, unfortunately, one student got a lung full of hydrochloric acid and felt too ill to continue in lab today. And so and she went to seek medical help this morning. And so be careful. If there's anything dangerous or potentially dangerous, do it in the hood. You know, this is why I made you guys weigh the dichromate in the hood, because we don't want to inhale that stuff. And also, if you don't know, you know, ask. You know, for safety related stuff, ask. You know, ask your partner or ask your neighbor or ask me. You know, again, like I said before, this is a little bit different. You can't go on cruise control in this lab. I mean, this lab is a much more involved lab. You actually have to participate in the driving for this one. Okay. All right, that's it then. I'll stop talking and let you guys get going.